The more important questions in differentiation. Question number 1. Question 1 says we are given x minus a whole square plus y minus b whole square equal to c square. We have to prove that 1 plus dy by dx whole square whole power 3 by 2 divided by d2y by dx2 is independent of a and b. Let's see how. Solution. So x minus a whole square plus y minus b whole square equal to c square. We differentiate it, so it will become twice of x minus a plus this will become twice of y minus b times dy by dx equal to 0 because c is a constant. From where we get dy by dx equal to minus x minus a divided by y minus. Now we find second derivative. So d2y by dx2 equal to minus sign outside quotient rule. So y minus b times derivative of x minus a, that will give 1 minus x minus a times derivative of y minus b, that will give dy by dx. Whole divided by denominator square, that is y minus b whole square. Now we have dy by dx as minus x minus a divided by y minus b. So we can put this value here. So when we put, then this minus sign and this minus sign will become plus. So we will get d2 by dx2 equals minus y minus b plus x minus a whole square divided by y minus b whole divided by y minus b whole square. I think it is clear. Here I have put the value of dy by dx. Because of this minus sign, this sign has changed to plus, and then x minus a and x minus a will become x minus a square and divided by this y minus b. Now we take LCM. When we take LCM, this y minus b will get squared, and then y minus b will come in denominator. So we will get y minus b whole square plus x minus a whole square divided by y minus b whole cube. So d2y by dx2 equals minus y minus b whole square plus x minus a whole square divided by y minus b whole cube. But in the question we are given x minus a whole square plus y minus b whole square equal to c square. So we can write here as c square. So we will get minus c square divided by y minus b whole cube. Now let's consider what is to be proved. So we have to prove 1 plus dy by dx whole square, then whole power 3 by 2 divided by d2y by dx2 is independent of a and b. So we have got the value of d2y by dx2 as minus c square divided by y minus b whole cube. Now we have to find out the value of numerator. So let's consider it separately. 1 plus dy by dx whole square. We put the values. We have got dy by dx as dy by dx equal to minus x minus a divided by y minus b. So we put this value here. So we will get 1 plus x minus a whole square divided by y minus b whole square, or y minus b whole square plus x minus a whole square divided by y minus b whole square. So as we know that x minus a whole square plus y minus b whole square divide this much will become c square. So we can write it as c square divided by y minus b whole square. So this is value of 1 plus dy by dx whole square. But we need 1 plus dy by dx whole square whole power 3 by 2. So let's take its 3 by 2 power. So we put power 3 by 2 on both the sides. So here this 2 will cancel this 2 and this 2. So what do we get in RHS? In RHS we will get c cube divided by, and this will become y minus b whole cube. So we have got 1 plus dy by dx whole square whole power 3 by 2 equal to c cube divided by y minus b whole cube, and d2y by dx2 is equal to minus c square divided by y minus b whole cube. So we put these values here. So when we put these values, then what do we get? Let's write it. So 1 plus dy by dx whole square whole power 3 by 2 divided by d2y by dx2. So we put the values. So we have got 1 plus dy by dx whole square whole power 3 by 2 as c cube divided by y minus c cube divided by y minus b whole cube, and we have got d2y by dx2 as c square divided by y minus b whole cube. So we write here y minus b whole cube. So y minus b whole cube, and here negative sign are left. So that I will put. So it will be minus c. Now, because it was in case of d2 by here there was minus sign and that I missed. So you must write it minus this thing. This is c cube divided by y minus b whole cube, that is value of 1 plus dy by dx whole square power 3 by 2, and d2y by dx2 is minus c square divided by y minus b whole cube. So this minus sign because of this will come in the beginning, then y minus b whole cube, y minus b whole cube will cancel out, and this is c square, this is c cube, so minus c will be left. Clearly this term 1 plus dy by dx whole square whole power 3 by 2 divided by d2y by dx2 is equal to minus c, which is independent of a and b, and that was to be proved. Now let's consider next question. Question number 2. If cos y equals x cos a plus y, where cos a does not equal to -1, then we have to prove that dy by dx equal to cos square a plus y divided by sine a. This is also a very good question. So solution: cos y equals x cos a plus y, or x equal to cos y divided by cos a plus y. Now we differentiate it. In RHS we apply quotient rule, so it will become 1 equal to cos a plus y times differentiation of numerator minus sine y times dy by dx minus cos y times differentiation of denominator. So it will be minus sine a plus y, and differentiation of a plus y will give dy by dx whole divided by cos square a plus y. Now from here, we can take dy by dx common from these two terms. So 1 equal to dy by dx common. This will become minus cos a plus y sin y, and here there are two minus sign in multiplication, so it will become plus sin a plus y into cos y whole divided by cos square a plus y. Now, if you remember, sin a cos b minus cos a sin b gives sin a minus b. Sin a cos b minus cos a sin b gives sin a minus b. If you observe, this is sin a cos b minus cos a sin b. So here a is a plus y and b is y. So we get 1 equal to dy by dx times sin a, that is a plus y minus y divided by cos square a plus y will cancel out. So we will get 1 equal to dy by dx times sin a divided by cos square a plus y, or dy by dx equal to cos square a plus y divided by sin a, which is required answer. Now let's see next question. Question number 3. We are given a determinant fx, gx, hx, then L, M, N, A, B, C. We have to find out dy by dx. In order to differentiate a determinant, we have to put dy by dx in one row, then plus dy by dx in second row, then dy by dx in third. That is dy by dx equal to d upon dx of fx, d upon dx of gx, d upon dx of hx. Leaving other two rows intact, L, M, N, A, B, C. Then we write plus. Now we differentiate second row. So fx, d upon, sorry, fx, then gx, then hx, then d upon dx of L, d upon dx of M, d upon dx of N, then A, B, C, plus. Now we differentiate third row, that is fx, gx, hx, L, M, N, then d upon dx of A, d upon dx of B, d upon dx of C. Now, differentiation of fx becomes f dash x. So it is f dash x. Similarly, this will become g dash x, and then h dash x. L, M, N, A, B, C will remain intact. Now, L is constant, M is constant, N is constant. So this row will become 0. And if any row or any column is completely 0 in a determinant, then its value is 0. It means this will become 0. Similarly, A, B, C are constants. So their differentiation will be 0, 0, 0. Then again, the value of determinant will be 0. Hence, our answer will be f dash x, g dash x, h dash x, l, m, n, a, b, c determinant there. Now, let's consider next question. Question number 4. We are given y equal to e power a cos inverse x. We have to prove that 1 minus x square y2 minus xy1 minus a square y equal to 0. Let's consider the solution. dy by dx. Differentiation of e to the power function will be e to the power function, that is a cos inverse x into derivative of a cos inverse x, that will give minus a divided by root of 1 minus x square, that is minus e to the power a cos inverse x divided by root of 1 minus x square. Now, let's differentiate it further. So we can apply quotient rule and let's write this dy by dx as y1. So now when we differentiate, so dy1 by dx can be written as y2. So y2 equal to, here we can apply quotient rule, minus a common, then root 1 minus x square, then differentiation of this, so that will become same, minus a e to the power cos a cos inverse x divided by root of 1 minus x square, minus differentiation of denominator 1 upon 2 root 1 minus x square times minus 2x into numerator e power a cos inverse x whole divided by denominator square. So that will become 1 minus x square. Now, let's simplify. So here, this term and this term will cancel out. And here 2 and 2 will cancel out and this minus sign will make this sign plus. So y2 equal to minus a times minus a e to the power a cos inverse x plus x e to the power a cos inverse x divided by root of 1 minus x square whole divided by 1 minus x square. Now, what we can do is we can open the bracket. So when we open the bracket, this minus a will get multiplied to this minus a. So we will get a square e to the power a cos inverse x minus ax e to the power a cos inverse x divided by root of 1 minus x square whole divided by 1 minus x square. Now, what we can do, we can shift this 1 minus x square to LHS. So let's write it, y2 times 1 minus x square equals a square e to the power a cos inverse x minus x a e to the power a cos inverse x divided by root of 1 minus x square. Now, if you observe carefully, so this is the question itself, that is y. So we write a square y, and here dy by dx we have got as minus a e to the power a cos inverse x divided by root of 1 minus x square, and that is present here. So in place of minus a e to the power a cos inverse x divided by root of 1 minus square, we can write y1 or dy by dx. So here we write plus xy1. So what we have got, y2 times 1 minus x square equal to a square y plus xy1, or we can rearrange it y2 1 minus x square minus xy1 minus a square y equal to 0, which is our required result. Now let's take next question. So next question is question number, it is question number 5. So question is, using the fact that sine a plus b equal to sine a cos b plus cos a sine b, find the formula for cos a plus b. So we are going to use this formula, and from there we shall try to get the formula for cos a plus b. Here we have to use the concept of differentiation. Let's see how. So sine a plus b equal to sine a cos b plus cos a sine. Differentiating with respect to x. When we differentiate this with respect to x, it becomes cos a plus b. Then we have to differentiate a plus b also. So this will become dA upon dx plus this will become dB upon dx. Here we have to apply product rule. So sine a will become cos a, then dA upon dx times cos b plus. Now we have differentiated sine a. Now we have to differentiate cos b. So this will give minus sine b times dB upon dx plus. Here again we have to apply product rule. So first we differentiate cos a. That will give minus sine a dA upon dx times sine b. Now we have to differentiate sine b. So that will give cos b dB upon dx times cos a. Now what we can do, we can separate dA upon dx and dB upon dx in parts. So we write it cos, sorry, a plus b times dA upon dx plus dB upon dx equals, if we take dA upon dx common from here, so dA upon dx, then cos a cos b, and dA upon dx here also, so minus sine a sine b. Then we take dB upon dx common. So if we take dB upon dx common, so here it is sine a here one term So dv upon dx, when we take common, so from here we get minus sine A sine B. And from here we get cos A cos B. Now, if you observe cos A cos B minus sin A sin B cos A cos B minus sin A sin B, it means we can write it as dA upon dx plus dB upon dx times cos A cos B minus sin A sin B. If we compare, so we can cancel this term from both the sides. So what do we get? Cos A plus B equal to cos A cos B minus sin A sin B, which is our required formula. Let's revise it because there is slight doubt. So sin A plus B is equal to sin A cos B plus cos A sin B. If we differentiate it, it becomes cos A plus B times dA upon dx plus dB upon dx equals, here we apply product rule. So side A will become cos A times dA upon dx, then cos B will be copied, cos B, and then we differentiate cos B. So that will be minus sin B dB upon dx times sin A. Then again we apply product rule here. So this will become minus sin A times dA upon dx times sin B. Then we differentiate sin B. So that will become cos B dB upon dx into cos A. Now what we do, we take out dA upon dx, then we get cos A cos B minus sin A sin B. And when we take out dB upon dx, then again we get same thing, cos A cos B minus sin A sin B. So we can say that it is equal to dA upon dx plus dB upon dx times cos A cos B minus sin A sin B. Now we can cancel dA upon dx plus dB upon dx from both the sides. So we get cos A plus B equal to cos A cos B minus sin A sin B, which is our required answer. Thank you for watching.